Hello. Yes, Mr. Venkat Prasad, you can start.
Yeah, hope my screen is visible.
Yeah, it is visible.
Yeah. Okay. So very good morning to everyone. This is Venkat from Genetics Bangalore. First of all, on behalf of Genetics and Farming Technology, we welcome you all to this webinar. So our Genetics is an Indian manufacturer of automation products. We provide products, systems, and solutions for various industries. Also, we offer didactic systems for academia, for technical education. So we established in the year of 1977, and our R&D division is approved by DSIR. We have an in-house tool room facility for tool and die machining. Genetics is an integrated manufacturing system certified company. So we have a pan-India service facility. Genetics have 15 plus branches in India and 3 overseas offices located in USA, Germany, and Dubai. So we have 200 plus support engineers globally and 50 plus dealers and stockers. So we have 1,000 plus OEMs and 17,000 plus direct customers. So Genetics is the authorized distributor for Automation Studio in India. So we have Mr. Akshay from Farming Technology to deliver the webinar today. So we have a series of webinar planned on different topics for this month, and today is May 23rd on electrical. If you have any questions related to the topic, please write in the question box, and we will sure address your questions for sure. Now I welcome Mr. Akshay to start the session.
Yes, thank you. Thank you, Mr. Venkat Prasad. I hope the screen is visible to everyone. Okay. Good morning, everyone. I welcome you all to today's webinar on electrical. So this will be our today's agenda. We'll go through the simulation of basic AC circuit and troubleshooting part. Then we will draw an DC circuit as well. With this basic DC circuit, we will draw with the help of illustrated example as well. This is one of the new feature which we have added in Automation Studio. Then after that, we will build one Y delta circuit, and after that we will see some industrial examples. So before I start with the demonstration, I would like to tell you about our company and our product. So we are FAMIC Technologies. We have 130 engineers and software specialists. We are ISO 9001 2015 certified company, and we were founded in 1986. We have total 3 branches. Our headquarter is in Canada, Montreal, and apart from that, we have 2 offices. One is in Germany and the other one is in India, Pune. So we have in-house expertise in software development. In software development, we have software engineering, database design and support. Then we have network support, multimedia applications, object-oriented and web-based applications, and real-time systems. We have engineers. In engineering, we have CAD CAE systems, pneumatic systems, hydraulic, mathematical modeling, electrical systems, automation engineering, instrumentation and process control, and we also provide training as well. And in industrial automation, we have PLC programming, SCADA systems, human machine interface, electrical controls, process simulation, and system maintenance. So these all are our products. So we have in total 4 products. We have Automation Studio Professional Edition, which is mostly used by industries. So this is used to create, analyze, troubleshoot, and validate the multi-technology circuits. We have Automation Studio Educational Editions, which is mostly used by schools, colleges, universities to teach their students. We have Automation Studio Live Manifold, which is now incorporated in the Professional Edition itself. So this is used to complete the hydraulic manifold software solution for design, coating, and prototyping. And then we have Andon Studios, which is mostly used for the Industry 4.0, and this is the complete solution to optimize your production. So our software is sold in more than 120 countries. So our main objectives is to build long-term relationship, effective support by phone, email, or online. And we have dedicated representative for each account. And these are our support materials. We have training videos, demonstration files, quick start guides, and many more. So these are some of our milestones. When we started our product, which in 1986, we were known as New SIM, then HydroSIM. Then we kept on adding new features to it based on the technology and the requirement of the clients and customers. We kept on upgrading our software. So currently we are using Automation Studio 7.1, and mostly by next month we will be updating to Automation Studio 8 version, so which we have added few more features into it. So our software is a multi-technology software which is used in many programs. So as you can see in this diagram, we have a hydraulic block manifold, pneumatic component sizing, then bill of materials, catalog manager, manufacturer's catalog. Then we have control panels and 2D and 3D HMI, digital electronics. We have teachware. Then we have different types of ladder logics, PLC, and block diagram. Then we have electrical controls, electrotechnical. So these are the programs which the software can be used. It can be used in mechatronics, industrial maintenance, aviation maintenance, electrical, diesel, agriculture, renewable, electromechanical, mechanical engineering, HVAC, marine technology, and automotive. So these are some of the benefits which can be useful for the students, teachers, and school. So for students, it will validate the theories which is studied in class. So whatever the theoretical knowledge students are having, so it will be very useful for them to understand via practical knowledge in Automation Studio. And also it will be very easy for teachers to make students understand with the examples, whatever they're teaching in textbooks. So with the help of Automation Studio, it will be easy for them to make students understand. So it can be easily handled by both teachers and students. So for school, it will eliminate the need to purchase the single technology software. As we saw in the previous slide, it is a multi-technology software. So if you have this software, it will be used in all the departments, be it mechanical, mechatronics, electrotechnical. So you don't have to use any other software. So one software and it will be used in all departments. So it will limit the purchase of expensive and often inaccessible hardware. And also it will train students on a leading edge tool commonly used in the industries. So also this software is mostly used in all of the industries. So when students will graduate, they'll have a good hands-on experience and knowledge. So this software, we have this e-learning and remote access. So the software can be used in schools, then in homes. It will have an access to Automation Studio from school or from home. So this will create priorities for teachers and students. So this will configure time restriction and access points. So students can complete their work at home as well, and then they can submit their assignments to their teachers, and this will help to gain their knowledge as well. So we are available in 11 languages in more than 120 countries, and we have this international presence as well, and it is used in high schools, career centers, colleges, universities, and workforce development. So these are few of the publications which we have in Automation Studio. So this is one of the examples we have. On the right hand side, you can see one of the example of the fluid power by Anthony Esposito. So all the circuits which are there in this publication we have in Automation Studio. So students and teachers can go through it and see what kind of circuits are built from these publications in Automation Studio. See, all the circuits are ready to simulate. All you have to do is get access to this publication, which will be there in Automation Studio. Open this publication, see all the circuits and simulate. So all the schematics from these books are ready to be simulated in Automation Studio. So this will adapt Automation Studio easily to your own curriculum. So this will all these circuits are can be simulated, and also you can create your own exercises as well. So with this you can have interactive exercises. To teachers and students can have interactive exercises. So you can build your own exercises. You can conduct exams as well, practicals as well, where students can build this kind of exercises and see what kind of questions are there, and they can solve these questions. So all these circuits, you can build it on your own, and you can add it in your curriculum or in your practical exams. So we have this digital twin of your own equipment. If we have any trainer kit with you in your colleges or university, this can be connected to Automation Studio, and this will duplicate your hardware equipment virtually. So you can control the hardware kit with the help of Automation Studio. So this will change the properties or create faults for troubleshooting as well, and this will ease transition from theory to practice. So this is, as I told you, the one of the new example or new features which we have added in Automation Studio, the illustrated library. So when I will demonstrate, I will go through all the libraries and I'll try to build one basic circuit with the help of this. So we will see this during the demonstration part. So the benefits of virtual plus hands-on experience will be, if you have only hardware, then only 2 students per unit can be used. And if you have Automation Studio, then 20 users of Automation Studio with all modules can be used for the trainer kits. So if you have only hardware, then hands-on training with equipment is only possible, and which will also be more expensive for you. And if you have Automation Studio plus hardware, then it will give you hands-on training with equipment, then virtual tests. You can have the troubleshooting scenarios, then you can validate the circuits. You can access hundreds of components, allowing to create many more circuits on your own. Then this will introduce students to circuit design software. Working with different types of ISO symbols will help with blueprint reading skills. This change of properties of components to illustrate different scenarios. So all these things are possible if you have Automation Studio plus hardware, and this will be quite less expensive as compared to the hardware. So this is one of the main feature which we have in Automation Studio, the manufacturer's catalog. So I'll take you through this once we start with the demonstrators. So these are the available manufacturers catalog we have. So all the components from these manufacturers we have in this Automation Studio, and all you have to do is configure the product. And once you configure, it will be ready to simulate. So also with every catalog, we have this test bench. If you want to test the component which you are trying to build in your exercise, you can test it on your test bench. So this is the partial list of industrial clients we have. So in every sector, we have different types of companies using our software. In aerospace, we have Airbus, NASA. Then in construction, we have Caterpillar, Hitachi. In agriculture, we have John Deere. In defense, we have Larsen and Turbo, GCP. And in forest, we have again John Deere, Kubato, AGCO. So we have, this is just a partial list of industrial clients. There are many more. So this is all about our company and our products and the list of clients which we cater to. So I hope the corporate presentation was clear to everyone. And now we can start with the demonstration part. So today we will be concentrating on the electrical part. So this is the interface of our software. On the left hand side we have this library where we have all the modules, right from hydraulics, proportional hydraulics, electrical controls, and digital electronics. We have different types of PLCs as well. And this is the electrotechnical library. Again, in electrotechnical we have two standards. We have IST standard and NEMA standard. Then we have blocks and HMI and control panels. On the top end bar we have this ribbon. The ribbon bar, we have this home, edit, view, simulation tab, and also in simulation we have this measuring instruments. Once you build your circuit, you can take care of these measuring instruments in order to measure the properties in your circuit. And also we have this teaching training material, so we will have a look into this. We have this technical books as well, and on the right hand we have this project explorer. So before we start with the electrotechnical circuit, we have to select the project as the electrotechnical diagram, so then only it will support. Okay, now we have this workspace of electrotechnical. So before I start, I'll take you through the library of the electrotechnical. So this is the library of electrotechnical. So we have this tree-like structure. So every time we double click on any of the component we want, so it will show all the components up below that. And again, if you go through it, we have different types of components. If in case you're not able to find any components, we have also this search bar. You can search a component over here and you can find it from here. So to start with, we will start with the basic DC circuit. And after we complete the basic DC circuit with this generic component, we will also try to build it with the illustrated library. As we saw in the presentation, we have this new feature of illustrated library. So we will try to build the similar circuit, the DC circuit, with this illustrated library. So, okay, I'll draw one basic DC circuit. So for that, first I'll require one DC source battery. I'll require one ammeter. So the components I'm choosing from is from the frequently used components. So every time I use or more circuits, more components you use, you will find it in the frequently used section. So these are all of the components which I frequently use. So you can find it here over here. So after ammeter, I'll require one resistor. And at start, to control the circuit, I'll require one push button. Okay, so these are the components I require for this DC circuit. So once all the components are there in the workspace, I have to right click and say zoom all components, so that it is easy for me to make connections. So you can see all the red ports. If I hover my mouse into the red port, it will change into the target point, and we can simply make the connections from here. Now I'll change some properties of the components. If you double click on any of the component, say for example, I want to change the properties of the resistor, I'll go into the data tab. So all these parameters which you can see are set by default, which can also be changed according to your needs and requirements. So for here, I want the parameter control of this to be slider. So I want the resistor to be into the slider mode, so that when it is simulated, I can change the settings from there. And currently it is, the resistance is around 1000, so I'll make it 100. And same, I'll make the maximum resistance 200. So this is how we can change the properties of any of the component you want. Okay, now if I have changed the properties, now in the simulation section, you have this normal simulation. So I'll activate this. And if I push, you can see now the current is flowing through this line, and you can see the currently the ammeter is showing the current as 0.2 ampere. So if I now change the settings for this resistance, you can see the change in the resistance and you can see the change in the current as well. Now, as I said, in this measuring section, in the simulation tab, we have different types of measuring instruments. So if I want to check any of the property at this line, we have different properties. So if I want to see the RMS current at this line, so currently the current which is flowing is around 0.34 ampere. Now if I change, so there will be change in the lines as well. Again, we have this in this troubleshooting section, we have different types of components where you can measure the properties of. We have this multimeter clamp. Even this will show you the properties, different properties. Now you have this ampere, then you can see the voltage from here. We have oscilloscope as well, so we will build one more circuit and then we will see how the oscilloscope can be useful. And you can also create some troubleshooting scenarios. So I'll show you one example of that. Now if, for example, if teachers want to create some troubleshooting scenarios and they want to teach their students how it can be rectified. For example, for this line, if I double click on this in the troubleshooting section, we have this option of cut. Now, if I want to cut this line and see what happens to the circuit, I'll activate the failure from here. Now I have activated the failure with the help of the troubleshooting scenario. Now I will simulate it. You can see the current which was previously showing as around 0.3 or zero point 0.4. There is no current flowing from this. Even though I'll change the resistance, there is no current flowing because we know that there is a cut on this line. So you can take help of this ammeter to see where it is wrong. So now if I want to see at this line, now it is showing us zero current. Again, you can change this, it will show as zero. So at any point you can place these two diodes and then you can check why. So that you can see clearly that there is no current flowing through this line, so something is wrong in this line. So we have this repair tool over here. So you can check the repair tool, you can click on the line, you can select all the failures. So currently there is only one which is cut, and you can check this. Now you can see once the repair tool is activated, again the current is flowing. So now if I change the resistance, now the current is flowing through the lines. So this was the basic circuit which we have built with this generic library. As I said, we have introduced new feature in Automation Studio, that is the illustrated libraries. So this is the illustrated libraries for all the modules which we have. For electrical, we have different library. Then for renewable, we have different library. Hydraulic, we have different library. So I'll select electrical one and we'll try to build a similar circuit from this library. So I have this electrical renewable energy library. So I'll try to build the similar circuit of this basic DC circuit from this library. So again, to start with, we have taken one battery. So the battery is of 24 volt. So we will take the same battery. Then we'll take one ammeter. So we'll require one resistor, and at last, to control the circuit, we'll take one push button. So these all are the components which we have taken from the illustrated library. So I'll zoom all components, and now I'll make the connections. So we have built the similar circuit with the help of this illustrated library. So we have used all same circuits, same components that we have built to this generic library. So now again, I'll start the simulation. So I'll start this one and I'll start this one as well. So now you can see the ammeter is showing the current passing through the lines. And from the measuring instruments, if you want to see the state of charge of this battery, so it will show you the state of charge. So the state of charge is around 46.5%. So as you activate this battery, it will keep on reducing. So this was the basic DC circuit which we have built, one with the generic components and the other one from the illustrated library. So we have built the same circuit. So I hope this part is clear to everyone for the basic DC circuit. If you have any questions, please do write your questions in the chat box so that we can address it later on. Okay, so now we can move on to the basic EC circuit. So I'll take one more new page. Okay, for now we will build one basic AC circuit. So to build two AC circuit, I'll require one three-phase source. Then I'll require a fuse disconnector. And then I'll take one asynchronous motor. So these three components are there, build one basic AC circuit. So now to make connections, if you go into this home section, you'll find different types of wires over there in order to make the connections for these circuits. So you can see there are different types of wires over here. Command wire, power wire, phase wire, ground wire, polyphase wire. Now you can see there are three connections. So directly if I choose polyphase wire, I'll be able to make connection for all the three ports. So I'll adjust my motor in line with this fuse and then I'll make the connection. Okay, once the circuit is built, I'll start the simulation. Now here you can see once the AC circuit is activated, I can change the load torque from here, and you can show it will show you the angular speed, it will show you the output torque and the variable load torque over here of this motor. Now again, with the help of this measuring instruments, I can check the properties. So here I'll take one component dynamic measuring instrument. So I'll check the current at this point. So we have different units as well if you want to check a different unit. And then I'll go for two node dynamic measuring instrument in order to check at 2 points. So this will show you the voltage at these 2 points. Now again, we have this three node dynamic measuring instruments in order to measure the property at 3 points or three nodes. Now this will show you the active power at these 3 points. So now if I make changes in the torque, you can see the change in the properties as well. Now we'll see, as I told you, we will see an example with the oscilloscope. So this is in the oscilloscope. So you can place two nodes and you can see the wavelengths in this oscilloscope. So you can auto scale it. You can change the wavelengths from here. You can either increase or decrease this. Then you can change the voltage from here. I can also move the cursors from here. I can change the position of the cursors. You can place at any point you want. And also I'll change the horizontal cursor as well. This is how you can change the cursor position and you can measure the properties. So this is how an oscilloscope will help you in order to check the properties with the help of the cursors or wavelength from. Even here you can see the delta voltage is showing over here. Delta t, the time is shown, and also the frequency is shown. So this was the basic AC circuit which I have built in order to show the properties of the oscilloscope and all three measuring properties we have. How to measure it, we have seen. So now at last we will build one delta circuit. Y delta circuit we will build. Okay, so now we will build one Y delta circuit. So again, in the electrotechnical section, so to start with, we will require an energy source. So here I'll take three-phase source with neutral. So earlier we had taken only three-phase source. So to build this circuit, I'll require one neutral as well. I'll require a fuse holder. I'll name this as fuse. I'll take a contactor. I'll also require one thermal relay poles. I'll name it as FR. And I'll require a motor. So over here I'll take one asynchronous motor, which will have 6 connectors to it, because we will be building contactors at the bottom of the motor as well. So one over here and one on the right hand side of the motor. And now with this source and neutral, we will require a circuit breaker as well. So I'll place a circuit breaker over here. And now if you want to change the position of any of the component, you simply have to check the component and control and H, or either control and R. Okay, once all the components are there in the workspace, I'll zoom all the components. And I'll make the connections. Here again, I'll take a build of this polyphase wire. So I've made the connections, and I'll just complete this circuit of this contactor as well. So we have built one part of this wire delta circuit. So now to complete, we will require an fuse holder. I'll name it as FU2, and then I'll change the position. I'll require one more fuse for this neutral as well. Just delete these names, and I'll place it near the line of the neutral. Okay. So I'll require 3 make contacts. So these make contacts we have to then variably link to the relay coils as well in order to activate this. And when we start the circuit, the lamp should ignite. So we will take 3 lamps for this. Now to control these 3 make contacts, 3 relay coils, and 3 lamps, we'll require switches. So I'll take one relay contact first. So here over here you can find different types of relay contacts. So from here I want this contact of a thermal overload. So this one I'll take. So I'll variably link this later on. So now from switches, so I'll take one pull switch which has break contact, and I'll directly connect this to this one. So till then I'll make the connections for this. Okay, so the connections have been made for the lamp and for the make contacts. So now I will complete on the right hand side where we have taken the relay contact and the switch. One switch we have taken. I'll take one normal push button. I'll name it as 1 SB1. And for this push button, I'll require one more make contact. I can assign later on. Once we have all the relay coils, we can make the variable assignment of this make contacts so that they are variably linked to each other. So now I can take 3 relay coils. I'll name this as KM. Now as we have 3 make contacts and 3 lamps, I'll take 3 relay coils. I'll name this one as KMY, and one more, name this as KMD. And I'll connect this to the make contacts and the lamps which we have taken. Okay, so when we simulate the circuit, all the relay coils should not get activated simultaneously, means once at once. So we will require a break contact as well, because once one relay coil is activated, the other one should be controlled. So I'll take one push switch button with break contact as well. Similarly, on the for the other relay coils, I'll do. I'll take one break contact and 2 make contacts for you. And at last for this KMD relay coil, I'll take one more break contact and then I'll connect this to this relay coil. Okay, so our wire delta circuit is almost circuit. We have almost made all the connections which were required for the circuit. And at last, all the relay coils which we have taken in this circuit, we have to variably linked to all the components so that it is linked to each other. So we will start with the ME contacts over here, which are connected to these three indicators or bulbs. So now you can see there is question mark on each side of this make contacts. So we have to variably link this make contact to this relay coil. So if you double click on the make contact, you will go into the variable assignment section and you have to search in the alias sections over here. So if I search KM, so this first one we will connect it to the first relay coil, that is KM. So I'll double click on this. You can see it is now changed into the blue color and the question mark is now into the KM. So both of these make contact and relay coil is connected to each other, that is linked to each other. So I'll select the second one. I'll connect this to the KY and the third make contact. I'll connect this to the KMD. Now, wherever you see the question mark over here on the switches or the make or break contacts, you have to link this to the components which we have taken in the circuit. Now for this relay contact over here, I'll directly connect this to this relay contact over here which we have taken. So this we have named as FR. Again this I'll variably link to the KM, that is the first relay coil. So now we have taken this one and the break contact. So this one should not be activated. So that is why we have taken the break contact over here. So again, this we will give it to the KMD. Only one relay coil will be activated. The other two will not. And this break contacts we will connect to the push button which we have used over here. So we have named it as SB1. The other one will give it to the SB2, and the third one we will give it to the relay coil. So we have variably linked all the components, connection switches to the relay coils or to the switches, then the okay. So at last we are remaining to this contactors. So even we will make connections to all three contactors to the relay coils. One for the first relay coil, this one we will give to the second relay coil, and the third one to the KMD, the third one. Okay, so now we have completed our wire delta circuit, and also we have linked all the components which we have selected. I guess we are remaining with this one break contact. Okay, so we have completed the circuit. Yes. Now maybe finally I'll try to simulate this. Okay, now we have taken help of 3 push buttons, so I'll see. Yes, now it's working. When I press this push button, you can see the motor is running, and also the first relay coil, this KM and KMY2 is activated. Now I'll push the second button, push to, now it is shifted to the other one. You can see the indicator's position is also changing. We can change the constant load torque from here, and at last the third push button. So now all 3 light switches are closed. So this is how the Y delta circuit works. Now in this fuse, I'll add one. I'll show you the tripping countdown function, how it works. So it will show you the time if in case the constant load torque goes beyond its level. So it will automatically deactivate or it will failure the mode. So now if I start the simulation, we can observe the timing or countdown tripping from here. Now if I increase at the certain level, so after I just reduce it a bit. So after around 7 seconds, the motor should automatically be closed and the circuit should go break down. So we will observe that if in after like 5 seconds if the motor is closed or not. So this is the function of the countdown tripping. So you can see after the 5 seconds the motor has stopped working. So this is the Y delta circuit. So you can build your own circuit if in case you have any circuits in your textbooks, you can build it over here. We have all the components from in our library. So I hope this part is clear to everyone. So we have total seen 3 types of circuits. We have seen one basic DC circuit. Also we had connected that to the illustrated library. Then we had seen some basic AC circuit, and at last we have built this huge Y delta circuit. This circuit also you can take help of the illustrated library. So you can try to build with that as well. So if you have any questions, you can write it down. So before I go, I wanted to show some examples so that you can understand the capabilities. So we are running short of time. I'll show you the videos instead of some files for this electrotechnical. So I'll show the similar one. The Now I'll show star delta instead of this. So I hope the video is visible to everyone. So this is the star delta motor stator. So here we have taken connected to the HMI, and then we have connected to the relay coils over here. Similarly, which we have done to the bulbs, you can take help of the HMI panels as well. Then I'll show some industrial examples. I'll show you a traffic light signal, how we can build and make connections from here. So this from on the right hand side we have created logic, and on the left hand side we have used the HMI control, then we have connected this to each other. So over here we have taken the help of the ladder logic, and then we have made the sequence of the animation from the ladder logic. So this was one example, and one more thing I wanted to show is the teaching technical training material. Okay, so once you go in the technical training material, so we have this technology for all the section. So currently I'll show you for the electrotechnical. So I have already, so into the technical, we have this list of activities, but we have this for physics, we have different types of laws over here. In order to teach the students, we have combination of registers. So here you can build the circuits, and on the left hand side you can create examples or questions for practice for students, so that it will be easy for students to understand how exactly it works. So different types of exercises are already built. You can create your own exercises, and then you can add it into your software for students. So different types of concepts are also there. Electric charge. So this will help students to understand the concepts, and also different types of components are also there. So I hope so far everything is clear for everyone. I'll go into the question section. If you have any questions, we will address that. If not, we can end the session. So I can't see any questions over here except for one, which software you are using. So we are using Automation Studio version 7.1, and we were looking into the electrotechnical module over here. So there was only one question. There is no more question. If not, we can end the session over here. Thank you everyone for joining.
Yeah, thank you, Akshay sir.
Thank you.
Finally, we are at the end of today's webinar. Hope everyone is good with the session. So, thank you, Akshay sir, for your time and your session. We have the next session on 24th Thursday on the topic PLC. So we have a separate registration link for each webinar. So please register yourself and with your peers. And if you have any queries about our products, you can please send us through an inquiry at genetics.co.in. Thank you. Thank you.